So the last thing that we're doing in this section is some applications, so some word problems. I want you to make sure you are paying close attention today to the work that I expect to see on these types of problems. So I did print them for you, so that you're not trying to copy down the problem, and you can focus on how we're solving them. So this first one, it says find two numbers whose sum is 10 and whose squares differ by 20. Alright, so if you remember from earlier in the year when we did word problems, you always get a point just for defining your variables. So I want two numbers. So I could say x is the first number and y is the second number. So if I have two variables, I have to have two equations in order to be able to solve this. So now I need to go to my problem and see if I can find two equations. It says their sum is 10. What does sum mean? Add. So x plus y is means equals 10. Whose squares differ by 20. What does that mean? Subtract. The differ is to subtract. Their squares would be like x squared minus y squared equals 20. Would I be able to solve this with elimination? No. So what would I have to do? Substitution. So the new part is we had to write our equations. To find our variables, write our equations. Now it's just like the stuff from yesterday. So we can't eliminate a variable, but we could substitute. So solve for x. So x would equal 10 minus y. And then I'm going to plug that into my second equation. So x would be 10 minus y squared minus y squared equals 20. So 10 minus y squared means you have two of those, so you have to FOIL. So 10 times 10 will give me 100, minus 10y minus 10y, so minus 20y. Negative y times negative y is positive y squared. What happens? Negative 20y, if I subtract over my 100, equals negative 80. Divide by negative 1, or by negative 20, and y is 4. And once I have y, I can get x. X is 10 minus y, so 10 minus 4 is 6. The other difference, since it's a word problem, I don't... So what I want you to do, instead of giving an order pair, since it was a word problem, I'd like you to write a sentence to answer. So my sentence, I just said find two numbers, so the numbers are 6 and 4. 6 plus 4 equals 10. 6 squared minus 4 squared equals 12. Where did I lose you? Other questions? Let's look at the next one. In a recent survey, the average number of texts sent by two age groups, 18 to 24-year-olds and those 55 or over, was 2,172. However, the number of texts sent by the 18 to 24-year-olds exceeded the number of texts sent by those 55 or over by 3,362. Determine how many texts were sent by each age group. So what am I trying to find?
How many texts each age group?
Right. You look at the question. We have how many texts by each age group. So those are my variables. The number for each age group. So X could be the number from the 18 to 24-year-olds. And Y could be the number sent by the 55 and up group. Okay, now I have to write my equations. So it says the average. How do you find an average? Okay. So in this case, there are two age groups. So I would add them together and divide by 2. And that equals
2, 1, 7.
So there's my first equation. Then it says the number sent by the 18 to 24-year-olds, so that was X, exceeded the number sent by the 55 and up by 3,362. What did I do with that? Okay, so X is the Y plus 3362, or you might have done X minus Y equals 3362. Just telling you how many more were sent by that age group. Okay. Substitution or elimination, what's going to be our best option? Substitution. I have my X already, so I'll just plug that into the first one.
Can you get rid of the denominator first?
Yeah, I probably would. So if you don't like that divided by 2, you could just multiply it over, which gives us Y plus Y is 2Y.
What?
Are you guys all with me here? Okay. So now what?
Subtract.
Subtract over the 3362. Divide by 2. And we get 491. And once I have Y, how do we get X? Alright, so X is 491 plus 3362.
I feel like once like that, we gotta show our work. I feel like you just kind of like put it in.
You mean for finding the X? Not necessarily. Okay, so the sentence we need to know how many were from each age group. So X was the number from the 18 to 24-year-olds. So the 18 to 24-year-old group sent 3,853. And 55 and over group sent 491.
Let's compare phone calls. I'm sure they send it.
Oh, I guarantee. Is that one okay? 2 more. I know, I'm not lying. A box with an open top. Alright, so I'm just going to go ahead and draw myself a picture. I'm talking about a box. Okay, open top just means there's no lid on my box.
Oh. This is where you're losing.
Oh,
It's not very good, but
Ah,
don't
it's
judge.
rough.
I just colored in the top. so I
I'm
have
five
no
years
idea.
old. Yeah, mine would be too deep. Sorry about you.
Okay. The first thing it says, it has a square base. What do you know about squares?
I
All
would
sides
say
are the same.
Okay, so I could pick a variable. If I say x, both of these are x. The base is square, so the sides are the same. This counts for defining my variables if I'm labeling it in my picture. And then 4 sides of equal height. Okay, did I tell you how tall it was? No, so I could call that y. Okay, and that's the height for all of them. So that's defining my variables. So then we have to write equations. The first thing, it says the volume of the box is 54. How do you get volume?
Multiply
Length
height,
times
length, and width.
Length times width times height.
So it's x squared times y.
Right, x times y, so x squared y equals my volume of 54. Second equation, it says the height, what's my height?
Why?
Y, is means
Equals
double the length of the base.
x squared. Or 2x.
Double just means take it times 3. All right. So probably pretty easy to do a substitution here. So I can go to my first equation and replace my y with 2x. So we get that x is 3. So y is 2x, so 2 times 3, so y equals 6. So I need the dimensions of the box.
Can you just put like 3 by 6?
You would have to do 3 by 3 by
Oh, 3 by
6,
3.
length times width times height.
Right.
And let's see, we were in inches.
Oh shoot.
Oh, you do it for every single one?
Or you could say the length of the base is 3 inches and the height of the box is 6 inches.
I like how your T star size a y. I think that's pretty cute.
Just an extra fancy
Yeah,
tea.
it is
Oh.
fancy. That T is amazing.
This is a cursive tea.
Yeah, that's not made correctly, as my kids have informed me when they learned cursive, and I don't write my letters correctly.
Thanks, Brian.
Can you talk about this?
No, I'm sorry.
No, no.
Drop your attitude, I'm tired of you already.
You're on and out. We're on that.
Alright, last one. We did interest problems earlier in the year, and we did them by making a table at that point. But I just wanted to show you another option. We didn't have to have a table, we could do systems of equations with them. And I think you did them in Algebra 2 with systems of equations as well. So it says a student invests a total of $5,000 at 3% and 4% annually. After 1 year, the student receives a total of $187.50 in interest. How much did the student invest at each interest rate? So we need the amount at each rate. So those are my variables. So x can be the amount at 3%. And y would be our amount at 4%. So now we need equations. The first thing we know, we invest a total of $5,000. So what would you do?
What's y?
The second thing we know is the interest. How do you get interest? which is
A equals P times 1 plus the rate over N.
that's for compound interest. Let's just do simple interest. Keep it.
Oh, PRT.
Mhm. Interest equals principal times rate times time.
Oh, stop.
So we're just gonna go easy. We're talking about 1 year, so the time is 1. So we just need the principal times the rate. So x, and what's the interest rate for x?
3%.
So it would be 0.03x plus 0.04y equals our interest, which was. Alright. Would substitution or elimination be easier on this one? Yeah, we could do either way. We haven't done any elimination today. Let's do one.
Oh.
If I want to eliminate my x, what would I do?
What about negative 0.02?
250.
What did you just say?
So 250.
Multiplied by the bar.
If I add those, my x's cancel. So we get 0.01y equals 3750. Divide by 0.01, what do you get?
Oh, I'll give it a subject.
When you plug that in, you know x plus y equals 5,000. So if we subtract that over, x is 1250. So the student invested $1,250 at 3%. And $4,750 at 4%. Is that okay with everyone? There is a handout posted on Classroom, and you have the rest of the hour to work on that.